Welcome to this TechAbility 3D printing webinar. Please press subscribe underneath the video if you want more of this content. And if it was useful, please hit like and leave us any feedback in the comments. So hello everyone and welcome to this 3D printing webinar from TechAbility. So we're joined today by Matt Daly, who has a long history with 3D printing and has some really interesting practical outcomes that he's had from it and can give you some starter tips as well as to what to use. So thanks very much for joining us, Matt. Are you signaling me something?
I was just waiting to be unmuted. Yeah, hi everyone, and thanks for having me, Neil. So I go ahead and share my screen now?
Yeah, that'd be grand.
Yeah.
And yeah, anyone, if you've got any questions, then feel free to put them in the chat and I'll either ask them throughout, or if I think it's better, then I'll put them at the end.
Yeah, so can you see that, Neil?
Yeah, I can. Yeah.
So as Neil mentioned, I'm just here today to speak to you about 3D printing, which I've been sort of involved with professionally now for a number of years. And more recently, in terms of broader innovation and working with startup tech companies, but I did spend a long time working at an independent specialist college, and that's where the start of my 3D printing journey began, and is probably what's more relevant to you guys that are here today. So I started working at Seashell, at the independent specialist college there, all the way back in 2004, and I worked in the residential part of the trust for 9 years, actually, working with the young disabled people aged between anything between 3 and 23. And then this role came up as an assistive technologist, and before that day I hadn't never heard of the term or didn't know what it was, and I read the job description and thought, wow, this is everything I want to do. I love working with these young people, but I'm a real tech head. I've got some qualifications in electronics and computing and graphic design, and it was a way of really combining those two things. And I spent 6 years working as an AT at Seashell, left in 2019. And for me, what it says here, assistive technology is using technology to enable someone to do something they couldn't do before, whether that be access education, access education, be more independent, or perhaps communicate. And as I'm sure many of you are aware, there are lots of off-the-shelf products that can help people, bits of software and adapted equipment, that kind of thing. But at Seashell, quite often the students' disabilities were so severe and unique, there wasn't an off-the-shelf solution available for them. And my favorite part of the job was then trying to problem solve what it is they want to be able to do, and can I kind of hack something to make that easier. And 3D printing was really a way of me doing that. Here's a map of Seashell just to give you an idea. So it has a residential part, a school and a college, and it was the college where I worked, and we were very fortunate in having a small assistive technology team there. And this is the 3D printer that we bought, way back in 2013-14. And I got lots of raised eyebrows when I bought it. People thinking I just wanted to make silly things with it, but I was adamant that there was a real use for it, and something that we could really make have benefit for the young people. It was certainly a steep learning curve, and I would say that to anybody who wants to sort of take on 3D printing for the first time. These things aren't designed yet to just be completely plug and play. You do need to maintain them. Prints often go wrong, but for me that was all part of the fun. So just for those of you who don't know anything about 3D printing, I'll try and give a bit of a brief overview of how it works. The type of 3D printing I'm going to talk about today is called FDM. There are a few different types of 3D printing, and like any tech sector, it's growing all the time. There's lots of new kinds coming out, people 3D printing in metal and using powders and big industrial machines at the size of rooms. But today, we're talking about desktop easily accessible, good starting point 3D printing. So they work using a spool of plastic, or filament as it's called, which is on a reel like you can see in this picture here. And there are a few different types, and again, more materials are coming out all the time. A really good starting material to use is PLA, which is, is a type of plastic, or ABS, which is a bit tougher, a bit harder wearing, slightly more difficult to print with, and that's what you'd find like a Lego brick being made out of. So the end part, it can be pretty strong. In order to get your model printed, you need a 3D model in the first place. So here's a picture of a part, and then you import that model into some slicing software, and the software basically splits the model up into lots of little layers. So if you can see in this picture, the grey part in the picture indicates what the model will be like when it's completed, and the red and orange bit is a cross section of that. So this will be a couple of thousand layers, this particular print, and as you can see from the bottom, it will take 21 hours and 51 minutes to complete. And that's a good thing to point out at this stage, that 3D printing is a slow process. You don't get the prints done quickly, and if they go wrong in that time, you have to restart. So it's really, really good for prototyping one-offs and doing one thing, a single item. If people would always say to me like, "Oh, why don't you sell that design? You'll make millions." And I said, well, no, because it's just for such a unique group of people. You'd probably only ever sell 10. So 3D printing is perfect for that. But if you're mass producing anything, 3D printing really isn't the right production method. So the spool of filament that we spoke about just earlier is fed through. If you look at the top of the Ultimaker machine, there's a black cable. So it's called a Bowden tube, and the filament is driven through that tube, and then it comes out of this very hot nozzle, which you can see I've circled red there, and it squirts out the molten plastic, bit like toothpaste, onto what they call the build plate, and it does one layer at a time. The print head moves around back and forth, this nozzle moves around back and forth, and the bed which it's been printed on slowly moves down as it goes, building up layer by layer. So I'd have a little time lapse of a print here. So it's just a short video. So as you can see, this is really, really sped up, but the print head's moving side to side, back and forth, and squirting out this plastic in layers about 0.1 of a millimeter thick, although that is something you can adjust if you want to increase the speed of the print that's coming out. And what you can see being printed here is a project which I'll go on to a bit later on. So I've put this picture in just as an example. So when I first started, there was a lot of trial and error and printing out things. And as well, to begin with, I had no 3D modeling experience and didn't really know, how to create the models in the first place. But this was a model I found off the internet, which was a pen holder for some Sharpies. And this one went wrong a number of times, and I figured out, I've got the settings not quite right, and it really helped me learn. So that's something I'd say, don't be afraid to download some files off the internet, even if they're not relevant particularly. It's all good and part of the learning experience. Whilst you get to know the machine and how it all works. So the three main areas of 3D printing that I thought we could use with the young people back at Seashell. First off, I thought it'd be brilliant to do sort of accessible sculpting. If somebody didn't have the ability to be able to work with clay or create 3D models themselves, I thought wouldn't it be fantastic if we could have some sessions where we digitally do a 3D model, and then we can see it being brought to life before our eyes. And I've crossed this out because 3D printing is so unreliable at times and is such a slow process. It actually was quite a frustrating thing for the students to sort of take part in. So it didn't end up really using it for that purpose. But what I did use it for a lot was repairing equipment, creating resources and learning tools. So in this next picture, you have to forgive some of the images that I've used, because I've really had to dig into the archives to find some of the stuff that I did at Seashell, because as I mentioned before, my role has changed quite a bit now. I don't do necessarily this sort of specific stuff, but if you look at the little blue circle and black circle, that was a part of a wheelchair that kept failing on a student's wheel, part of their foot plate. And when this part failed, we had to wait for wheelchair services to come in and replace the part. And during that time, it often meant that the student couldn't use their wheelchair that day. And I realized the part that was failing was a really simple bit of plastic. So the blue one is where I've replicated the part, and I could use that as a temporary fix before wheelchair services could come in properly. If you see the white little valve, that was a piece of equipment that a student used every day, and that little valve part broke. And this piece of equipment, I think, was several thousands of pounds, but it was no longer manufactured and we couldn't find that part. So again, I replicated that little valve, and it meant that that piece of equipment could continue to be used. The green square with the black stripe on it, that was part of a project to help young people learn Moon, which is a type of braille. So there was one corner had the corner chopped off, and that indicated that was the top right, and it was to help a student learn braille and Moon for the very first time. So there's just some examples of some of the stuff we did. But I'd like to go into more detail about 3 projects that proved to be really, really successful. And this one here, again, apologies for the kind of quality of the image, and I'm not expecting you to read that article, but it's the only place I could find the pictures. So this was a young lady, Emma, and she used a specialist cup, which she'd used for a long time, and Emma could drink independently. But what she couldn't do was put the cup back down on the desk. She couldn't rotate her wrists down. So for 21 years of her life, she'd always relied on having someone with her to have a drink so she could hand the cup back to them to be placed down on the table. And one of the occupational therapists, Rachel Johnson at Seashell, came to me and said, "Matt, can we use your 3D printer to create a better cup dock, for want of a better word?" And Rachel had actually kind of crafted a dock out of some old Robinson squash bottles, which got thrown away because the cleaners thought it was rubbish. And so we worked and we created a couple of the prototypes and came up with this wedge shape, which you can see in blue here. And that allowed Emma to be able to put down her cup and pick it up again. That was really, really cool. And that was probably the first bit of modeling that I did properly. Because I'd done a few basic bits, but this was the first kind of decent model that I'd made that had really had an impact on one of the students. The next project I'd like to talk about, there is a little video to go with it. This was a competition by an outfit called Drake Music, who do music with people with disabilities effectively. And it was a competition to win, I think it was £1,000 to build a musical instrument for someone with a disability. Now, the young man you can see there on the left is Samir, and he's a fantastic singer. But what Samir was unable to do because of his various disabilities was play an instrument. And what he really wanted to do was play the saxophone. So here is the video we sent into Drake Music to apply for the competition. So I'll play it now. The audio is terrible. I apologize.
Samir, would you like to tell people the things that you do in Rock Band? What things do you do?
Play instruments over the play.
You play some instruments, and what instruments do you play?
Drums and cymbals.
Yes, you're amazing with the cymbals. Can you remember the beats you use on the cymbals? How many beats do you play?
1, 2, 3, 1, 2, 3, 4.
Yeah, so you play a 3-time beat and a 4-time beat, and you're very good at both of those, aren't you?
Yeah.
So that's excellent. Can you remember what songs you sing in Rock Band?
Sitting on the dock of the bay.
Sitting on the Dock of a Bay, and there's another one, isn't there?
Stand by me.
Stand By Me. Who wrote Stand By Me?
Let It Be.
Well, yes, you assume Let It Be as well, yes. And who wrote Stand By Me?
Benny King.
Benny King, that's right. So, Samir, me and Matt have been talking about an instrument for you in Rock Band. Okay, and we think that the instrument that would suit your style of music is a saxophone.
Yeah. Well,
Do you like the saxophone?
play saxophone before.
You've never played the saxophone before. What about if you had the opportunity to play a saxophone?
Yeah.
Would that be good?
Yeah.
It'd be cool, wouldn't it? So that's what we're going to try and do. Matt and I and Holly, we're going to try and design a super saxophone just for you, Samir.
Yeah.
How good would that be?
Please.
You'd be very pleased.
Yeah.
Not only would you be a lead singer, and you're already the star of the show, but you could be the lead saxophone player as well.
Yeah.
Be good, wouldn't it?
Yeah.
Why wouldn't Samir be able to play a saxophone like a typical person could?
Okay, so I think one of the issues that Samir has is he certainly has a lack of breath, and he also has difficulty feeling with his fingertips, so that would be an obvious issue for him. And obviously the position and the way the saxophone fits would be quite hard for Samir to use, so we need to look at all those aspects.
How would you envisage that Samir would play the saxophone when performing in the rock band?
So the idea about Samir having a saxophone was for him to have the ability to improvise over any music within the right key. So Samir sings 2 songs in the key of G in the rock band, so we would program the saxophone so he could effectively just play pretty much any note and it would fit in with the key of the song. And that's how I see him using the saxophone. It's pretty cool.
Yeah, that's awesome.
So we have this idea to make a saxophone that Samir could play using switches rather than needing to have the force of breath to blow the actual saxophone. Now, it's quite an ambitious task because obviously there's some complications with getting a sound out of the mouthpiece of the saxophone. And I've had several goes at prototypes, 3D printing some fans, which we've had a kind of mixed success with. Basically, we're not being able to get enough pressure from the fans to blow through the mouthpiece to get a sound out of it. So the next plan would be to use an air compressor. We bought a really cheap one that you'd use for inflating the tyres on a bike, and tried hacking the nozzle to blow through the mouthpiece. But again, we've not got enough air pressure there. So if we were to be successful with the proposal, we'd like to use a more substantial air compressor that could get a note out of the saxophone. The second part of the challenge is to then how we would adjust the notes on the saxophone. So we've got a plan using perhaps an Arduino or another microcontroller operating solenoids that would open the keys to play the notes, and then Samir would use a foot switch to change the key or the note that's been pre-programmed immediately. We've had the kind offer of help from some of the other guys in the Drake music community. We've got some more expert knowledge on how we might best achieve it. So I'm really confident and positive in the hope that we can really take this project and get a working prototype that Samir can play and then perform in the rock band with, which would just be fantastic.
Like he's never been away.
that gives you, you know, an idea of the project. And we went on and built this, the breathless auto sax, which, you know, took some doing, but it was successful. There were some real challenges to overcome. First was the mouthpiece, and I was very naive when I took on the project and didn't really understand. I'm not particularly musical myself. How the kind of mouthpiece worked with the reed, and just blowing air over, blowing air through it doesn't work. You know, there's quite a lot of mouth control you need. So I had to create a special 3D printed mouthpiece and reed, and without the 3D printer that wouldn't have been possible. And then connect that to the air compressor. So when air was blown through the mouthpiece, it would sound the horn. So that was kind of challenge 1 done. And we rigged that up with a switch that Samir could operate with his mouth. So whenever he pressed that, it would release air out of the air compressor, blow through the saxophone and make a sound. So that was sort of the first job done. And the second job was, there's some more pictures of the air compressor working. The second job was working out how to change the note. So we worked out a way of having a range and being able to flip through the notes in that range, doing some electronics using a microcontroller called an Arduino, and then soldered all that together and attached it to the saxophone itself using this kind of sleeve, which you can see on the 3D printer here, which held the solenoids or electronic switches, which pressed the paddles of the saxophone in the right order. So it then would change the note. So here's me modeling it. So there was a foot switch which changed the note, and then a switch you could operate with your mouth, which blew air through the saxophone. So really, really cool project. Took a lot of doing, but you know, really impactful for Samir to be able to have the opportunity to play an instrument like that. Some more pictures. This next project I did at the start of lockdown, and I was approached by a kind of group of other similar-minded people to see if we could do something to help with the pandemic. You know, I felt pretty powerless, stuck at home, and I had these skills. Was there anything that I could do? And we focused particularly on residential settings and care homes, and how we could reduce transmission of, you know, potential transmission of COVID. And we came up with designing a tool which you could keep in your pocket and have part of your sort of your tool set as a carer, that you could use to, you know, open doors, press buttons, all that kind of stuff. But it would be retractable, so that anything that you did touch with the device would be tucked away, so keep it clean inside your pocket. There's another video, this one's not quite as long, just demoing the tool. I'll show you now. So I'm going to press this link. So what we did with that, so we could try and get into as many places as possible. We made it an open source design that was freely available to download from a website called Thingiverse, and that meant that anybody with a 3D printer could just download that digital file, put it into their 3D printer, and hopefully produce the same thing. Hopefully you can see this web page I've just opened up now, but this is Thingiverse.
Not yet, Matt. Sorry, you need to just reshare your screen for the new window, I think.
Okay.
I anticipated it because I get that wrong all the time.
Great. Can you see it now?
Yes, we've got it. Thank you.
Great. So this website, Thingiverse, is great and another really good starting point because it has lots of designs that people upload for free, and you can explore different ones and download. You could type into the search thing just accessibility. They ran a really cool competition a few years ago, actually, about accessibility, and people were encouraged to create designs that would help the disabled community. So that was really cool. But this was my No Touch multi-tool, which I uploaded in May 2020. And it's been downloaded 277 times. So I hope that it has helped someone along the way. But as you can see, there's a render of the design. And then this was the different parts that it printed out in. So there's 3 parts to it printed out. And then it could be assembled into the working product, if you like. So I'm just going to go back to PowerPoint. So
that's a really useful link. I've just shared it on the chat.
Yeah,
and I've also just shared the category of special ed, because that seemed to have some similar things that people might be interested.
Okay.
Are there any other categories within there that you'd recommend looking for or having a look through?
The featured categories are always really good, because with I'm sure you can appreciate, like anything, with it being so open source, you get a lot of rubbish uploaded, you know, and a lot of stuff that isn't so useful, and even some models that don't print particularly well because they've not been designed well. So that could throw you off. You could think that you're making a mistake in your printing process, but actually it was in the model. So I tend to find, if you're looking for some example models to download, stick to the featured models because they've kind of been verified and checked.
You can see all the ones with the hearts, can't you, as the people that have favorited them. So.
Liked it. Yeah, there are a few different sites similar to Thingiverse. Some which are sort of monetized, so you pay a few pounds for a model. But in my experience, Thingiverse is probably the best. Okay. So here are some printers that I thought might be useful to share. Now, there are hundreds and hundreds of models of printers, but these are 3 that I've used fairly extensively and can kind of vouch for in sort of a beginner's, medium and expert, if you like. And as you can see, you can start your 3D printing journey with a good printer called a Prusa Mini for as little as £382. This model in particular, at that price point, comes as a kit which you build yourself. So if you're like me and you like tinkering, that's part of the fun, you know, and you put together, it comes with instructions. You can pay, I think, about £50 more and it will come assembled. But I do recommend, you know, if you're trying to learn about 3D printing, you know, building the machine itself really helps when it comes to maintaining and fixing it. Things like the nozzles get clogged sometimes, or the parts need oiling. And if you've had that experience of putting it together, it really helps. And a really good middle of the range printer, the Ultimaker 2. The Ultimaker as a brand has a bit of a range of printers that go up in price. But this is the one that I bought originally at Seashell, and that printer is still working today. And it's a great printer, really. Lots of online support, open source stuff to do with that as well. And then for sort of really functional parts, the Mark Forged range of printers, you know, they can print out some really high-end stuff on there, and much more reliable printer, but it is more expensive. And one of the drawbacks of the Mark Forged is you have to use their brand of filament, their plastic. So that also increases the price. Whereas with the Prusa and the Ultimaker, you're free to shop around at different manufacturers of filament. And then some resources which you may find useful. First, we've spoken about Thingiverse. But then when you do want to get into the realms of designing your own models, Autodesk, kind of, I would say, the industry leader when it comes to 3D modeling software, and they have an entry-level website called Tinkercad, which is free to use, and I think is geared towards the use in the classroom and for young people to really get to grips with 3D modeling for the first time. It works in a way where you drag in solid objects, and then you use other objects to subtract from that object. So it's really visual and colourful and easy to learn. And I think they even have some lesson plans on there. So if any of you are working with sort of more able young people than ever I ever did at Seashell, then that could be a really good resource. But you do quickly with that find there are limitations, and like with me, with the cup design, I did that in Tinkercad. That was a simple wedge shape that with a dip out of it that would work fine. But then by the time I got to the point of doing things like the auto sacks, that was more complex modeling needed. And that's when you naturally go on to Fusion 360, which again, I think you can download as a kind of temporary user for free to have a play around with it, and then as a subscription model associated with that. But I found it there's lots of resources like YouTube videos and things like that. I taught all of it myself. I think it is quite accessible for people to get into if you've got the inclination. And then finally, I just wanted to finish off with how you can get in contact with me. If you've got any ideas for a project you'd like some help with, or even just some further advice, I'm happy to help with that. I set up my own company last year, ProtoMD, alongside doing some consultancy work as well. If anybody's got some ideas they'd like to speak about, please get in touch. Got my email address there, and then on the socials it's @proto_MD. So I'm going to stop sharing now, and if anybody has any questions.
Great, thanks, Matt. That was really interesting. So if anyone has any questions, please feel free to ask. Also, let us know if you've had any experience with 3D printing, or if you're thinking of starting out and what you want to do with it. By the sounds of it, Matt, it looks like it isn't enough just to get the technology and just start using it. You have to be able to have some kind of creative process of bringing either issues that need solving, or kind of ideas of ways it can be used and things like that.
Yeah, I mean, it's a real time. You have to devote a lot of time to it, and we were fortunate at Seashell, and I know this isn't the case, sadly, at all, specialist colleges, that we had me as a full-time AT, and I was given the freedom and the budget to be able to explore things like this. It does take a lot of time and patience, and it does go wrong. But it's amazingly satisfying. I can't stress that enough. If you've modeled something digitally, and then to see that come to life and be a real thing, a tangible thing you can hold, is a really satisfying experience, and well worth sticking to if you've got the time for it.
Yeah, that's great. So yeah, Sheena said that she's been learning to use Tinkercad, said it was easy to pick up, very user friendly. So they're using Blender, which is another free app. I know that's to do with 3D design as well, isn't it?
Yeah.
And eventually working their way to start 3D printing.
The only thing with Blender that I found is that I think it's more geared towards visual 3D models that you would view on a computer screen, and less sort of specific. So with all these packages, yes, you can export in the right file type, but I would, unless you'd already gone a long way down that journey, I would steer you towards Fusion 360, which is much more specific towards 3D printing, if that's what you want to use it for.
Okay, great. Thanks. We'll end the webinar shortly. So just if you've got any last minute questions or any comments that you want to say about how you found today, and if it's useful, or if there's anything that we've missed, then let us know. Mike said he's got 2 FDM and an SLR printer, and a real passion for it, trying to get the college involved with their new business enterprise course. Is there any form of funding out there?
So there isn't any funding that I know of, but what I will do is I'll have a look after this, and if I could come across anything, I'll share it with Neil and get it sent out to you. It would be great if there was, because that's another barrier, isn't it? The price of these things and the equipment that goes with it. But yeah,
always. Matt, would you be okay to put your one of your contact details in the chat as well, just so people can access that if they can't see the slide? Thank you, that'd be great. And what I'm going to do as well, I'm just going to put our funding webinar in the chat, just in case anyone hasn't seen it, which gives you a kind of general overview, but it obviously isn't specific for 3D printing. And Sheena's right. If you're a carton centre, then carton are really helpful with those type of things. The other thing I'd say is if you're part of NatSpec colleges, it's worth getting involved with the Champions project, because if all you have is a kind of one-off, as Matt says, it's good design for kind of, you know, just a few small pieces, then there's no reason why we can't link colleges together that have a 3D printer and another college that has a kind of an aim or a project or a solution for a learner. So stay in touch, and if you're not a tech ability, a NatSpec college, then just drop us an email and we'll see if we can put you in touch with someone who is. It might be a good way to kind of dip your toe in with.
Another thing, Neil, like the very first project I did around 3D printing, we didn't have the 3D printer in college, and I used a 3D printing bureau to print a key guard for an iPad. It was a custom-made key guard, which a therapist had been getting laser cut at quite an expense previous to that, and I said, well, we could 3D print this. So that I went to a bureau, and there's loads of those. They will just give it, 3D printing bureau service, and again, that's a good way of dipping your toe in, like you said.
Have you got any links to that at all? Not necessarily now, but
yeah, I can share them afterwards. Yeah,
that'd be great. That'd be a really good way to try it. And actually, a key guard is one that's come up before, so I think that would be quite useful.
Yeah.
Great. So we'll just last few minutes now. If you've got any questions, then get them in now. Martin said Udemy do a really good starter course on Fusion 360. Really helpful and very cheap. Okay, that's good. A good way to understand what you're doing. So I'm going to share our kind of closing slide now. So if there's anything that you found useful today, then get in touch. If there's anything, obviously for Matt directly, just get in touch with him. If there's anything you want to know from us, you can email us at techability@natspec.org.uk. Catch us on Twitter at tech_ability1. We've also got our website there with webinars and all sorts of resources. Just remains to say thanks to Matt. Thanks so much for your time.